Hey everyone, welcome back. So in this question we are going to understand today weekly contest problem 159, and this is the question number 4 Q4, and the question is saying that we have to find the kth smallest path XOR sum, right? So this is the title of the problem, that kth smallest path XOR sum we have to do, right? What is this? Let's understand. You pause this video and go through the statement. So question is saying that you are given an undirected tree rooted at node 0, right? Means the tree is undirected, means there is no directions given, right? Means from one node to another node there is no directions given, and this tree is rooted at node 0. Start from root node, that is called node 0. There is n nodes we have given, which is numbered from 0 to n minus 1. It means it is a 0 index array we have given, right, for the each node. Next it is saying that each node I has an integer value, that is called vals at I, and its parent is given by par at I, right? Means we have given a node I. Let's suppose each node I has an integer value. We can get the value from here, right? So if you think what is I, so right, I is a node, and if you want to find the node value, you have to just pass vals at I, you will get the value, right? Integer value. And its parent is given at par at I, right? Its parent at I. So the question further saying XOR path XOR sum, right? Path XOR sum we have to do. How? The path XOR sum from the root to the node U is defined as bitwise XOR of all vals at I for node I on the path from root node to node U, right? Means the path XOR sum from the root node, right, to node U is defined as the bitwise XOR of all the vals at I for node I, okay, on the path from the root node to node U. Understand? Means on the path of on the path from the root node to node U, if the nodes are coming, nodes I is coming, so we have to XOR all of the vals at I for node I on the path, right, where we are going from root node to node U. It is also saying inclusive, right? Next line it is saying that you are given 2D integer array, that is called queries, where queries at j we have given u and k. For each query, kth smallest distinct path, right, XOR sum among all the nodes in the subtree rooted at u. So if there are fewer than kth distinct path sum in that subtree, return -1, otherwise return the value. So we have to return the integer array where jth element is the answer of the jth query. In the rooted tree, the subtree of the node V includes V and all nodes whose path to the root passes through V, and that is V and its dependent. Okay. So what example is saying? Let's go through the example also. Let me zoom out a little bit. I hope it's good. Or you zoom this part, right? So the example is saying we have given the input is given as parent array, then we have given vals, right, and then we have given queries, right? So each queries, how many vals are there? 3, right? And so the queries should be also 3. So 1 query, 2 query, and 3 query, right? So its parent should be also there, -1, 0, 1, 0, 0, right? Means for the first node it's a parent. Let's suppose any of this there, that is called parent, right? And then for other we have 0, 0. Okay, so let's suppose node 0 having its parent is -1, means there is no parent, means the first node itself is, you can say, it's a root node because there is no parent. Okay, then we can say 1 and 2 is there. So 1 have parent 0, 2 has parent 0. So we can say the very first is giving what? -1. Then we have given 0, and then we have 0. Means from here itself we can build the tree, right? So you can build the tree how? We have given in the parent itself, means the first node itself having what? -1, right? And then we have 0 0, means next two node we have is 0 0. So it's 0 0 means this is your parent, right? And we can say what is the value of this, right? So all the values we have given, if we want to find the value of the node, right? So what is the value of the ith node? We can get what? 1, right? Then we have given what? 1, then we have get 1 1, like that we have given. So just you take the, let's suppose the path job is node 0, we have given what? 1, and the node 1 is what? 1 job 1, right, is equal to 0. Now it is saying node 2, so 1 job 1 is coming what? 0, right? And so the subtree of the rooted at node 0 includes what? 0 1 2, right? And the path job is 1 0 0, and so we'll say the distinct jobs are 0 1. And if we'll find the queries is saying that the queries at 0 is 0 1, queries at 1 is 0 2, queries at 2 is 0 3. So 0 and 1 is the smallest distinct path job in the subtree of node 0 is 0, and the second smallest distinct path job is the subtree of node 0 is 1. Since there are only two distinct path job in the subtree, will return answer is -1. And then finally we'll say 0 1 -1. Okay, so I hope you understand this problem. If you have any doubt, right, so please ping me in the comment box. So we have gone through the statement, what the statement is saying. Now we'll understand what the question is saying that. Okay, so let's understand what the question is saying that, right? So the problem statement, if you don't understand, then it's very difficult to just what we have to do, what is the intuition, and what approach we are going to do that, right? So just understand the problem statement in very simple steps, right? Let's go understand. So the very first step, it is saying what we have given, right? So means what you have given. So first of all, we have given a tree, right? The tree we have given. What type of tree is? Leave it that for now, right? So we have given a tree that is called let's suppose anything, right? And a tree we have given, and how many nodes we have given? N node we have given, right? That start from what? 0 to n minus 1, right? Means first of all, this is the very first step, means we have given what? The tree we have given. Understand? We have given a tree with n nodes, that is level from 0 to n minus 1. Understand? Next, it is saying each node I, right, has an integer value vals at I, right? There is a value at I we have given for each node. Each node contains value, right, that is given at vals at I. There is also we have given its parent is given by pair at I, right? So let's suppose another thing we have given what? Pair at I, right? So the parent array, you can say array or an array, sorry, an array that is called parent, right? It is it tells us who is the parent of node I, right? Who is the parent of node I, right? So node 0 is the root node, so its parent is what? Let's suppose in this case this root node is what? This is the root node, right? So what is its parent? Its parent is -1. Okay, now think the path job sum, right? What we have given, right? Sorry, we have also given, we forget that we also given what? Vals. So let's suppose second thing is this given, this in third thing we have given vals. So vals, an array vals we have given, that is called vals at I, is the value of node I, right? So these three things we have given. Okay, now what are the things, other things they given? Just forget for this line, you forget, right? Just forget what is saying that. Now think what we have given. You are given what? Queries, right? Queries array. So the queries we have given like this, and we have to find the smallest distinct JOR path, right? Path JOR sum. How we are going to do that? That we will understand later. Just think that what are the things we have given, and this is the fourth thing that we have given. So we have to extract the things what are we have given, right? Always what is the big problem saying that just extract the things that we have given, right? So you have to extract these things what we have given, that you have to extract. Understand? Easy, don't worry. Okay, now think what are the queries we have given, right? Means the part we have given, vals we have given, and the queries. So three major things we have given as an input. It will be given, right? What are the things will be given? Your parent array will be given, vals array will be given, and queries array. All these three arrays will have given, right? Tree is not given, so just think this. Another thing also we have given is a root node. You can say tree node, right? And the tree is level from 0 to n-1, right? But it is not given in the input. Challenges, you have to understand the challenges also, right? So just think about what we have to do, right? So for each queries that we have given here, right? For each query that we have given here, so in a subtree of node u, let's suppose there is node u, right? You have to understand, right? Here it was given somewhere, yeah, u and v, right? Like this. Okay, so let's suppose we have a subtree of node u, right? And it includes u and its children, right? So let's suppose any array is any subtree is there, right? Subtree of u we have given, so it will include its u as well as its children. Understand? So this will become what? Subtree. That we understand. So we have to calculate the JOR of values from root node to the each node. So if we'll start from here, the root node itself, we have to go for all the nodes, right? And then from all the JOR value, we have to find the kth smallest what value. If there are fewer than k, right, different JOR value, we have to return -1, right? It is very similar to the problem that we have given in this week. If you observe, right? So we have to find the kth smallest. You can see it is a 1 based index, not 0 based. It's a 1 based index. Okay, and there are you can say fewer than kth different JOR values, then we'll return -1, right? That we have given, right? The subtree you have given, if there are fewer than the kth distinct path JOR sum in the subtree, return this one. Clear? I hope till now it's clear. So let's understand the key concept, right? What are the key concept we have given here? Okay, so just think that we have given what are the concepts includes here, right? So apart from the given things, understand. So first of all, we have given what? This path JOR sum, right? So if I talk about the path JOR and sum, what is this path JOR sum, right? Means we have to do what? We have to do JOR of all nodes. What we have to do? We have to do JOR of all nodes from where? From it's saying root to node u. Means let's suppose we have to do from root node, from let's suppose root node is 0 to node u. Simple. So this is the concept we have to use. Okay, what the other concept we have given, right? Go through this. Yeah, the smallest distinct JOR among all the nodes in the subtree rooted at u. So another concept is saying here, right? Means we have given what? Subtree. So the subtree that includes, right, all the nodes, right? Subtree all nodes under, you can say, a node including, you can say, including itself and its children, right? You know the subtree, right? So first we have given what? Path XOR sum, and then we have given subtree, right? So what is the subtree? All nodes under a node including itself and its children, right? If we'll talk about this is the parent, if it is u node u, there can be multiple nodes are there, then let's suppose this is a parent. But if we'll talk about this is a subtree, this is node u, so node u contains two children, right? Means if we'll talk about the subtree, this subtree means this node u and its children. Understand? Easy? Give me 1 second. Yeah. Now in the last what we have given, right? Yeah, we have given the kth smallest distinct path, right? So what is the kth smallest, right? The third concept that we have given, let's suppose I'll write here kth smallest. What is the kth smallest? Means if we will sort the value and will pick the one at a position k, that is the kth smallest, right? Understand? Means first of all, the values that we have given, we have to what? We have to do sorting, right? After the sort, we have to pick one at the position k, and that will become what? At position 1, that will become what? Kth smallest one. Understand? So now understand this example that we have given, right? Example 1. So what we have given? Parent we have given -1, 0, 1. Sorry, 0, -1. Then we have given what? 0, and then we have given 0. This is nothing but your parent array, right? You can say pair. I'll say just parent. Okay, so we have given this. Then we have given vals, and then we have given queries, right? You can write like this. As similarly I have written for the parent, right? Means if we'll say what is the meaning, right? What does it mean? Means this is a tree, right? It means at 0 it is nothing of the val is 1, right? Val equal to 1 at where? At here. Am I writing correct or not? Right? So at here, what is this? We can say val equal to 1, right? You observe, you can see here, right? We have given the vals. Then if we'll talk about at this level, what we have given the vals? These vals we have given is 1. Here we have also given 1. So if we'll talk about this position, we have vals we have given, means values we have given 1. Understand? Now let's compute the XOR path XOR, you can say, for these things, right? So as you can see, we have given path XOR, right? So for node 0, right? Node 0, it is 1, right? Node 0, it is 1. For node 1, what we have given? 1 XOR 1, right? If we'll do 1 XOR 1, what will come? 0, and that is it is coming. Similarly for node 2, 1 XOR 1 is 0, and it is coming. And so the XOR path is becoming what? 1 0 0. Understand? So this is coming, right? The XOR path is coming what? 1 0 0. Now we have to find what? Subtree of 0. Subtree of 0. So now it's time to find using the queries. So now you have to see the queries. What are the queries we have given? So let's suppose the queries that we have given. So these are the queries that we have given here, right? These queries. The very first step, queries at 0, we have given what? 0 and 1, right? This 0 and 1 we have given. So if we will find the subtree that is rooted at 0, right? And it will includes what? All, right? If it is given, right? Let's suppose the root we have given what? 0. So what are the childrens are there? 1 and 2 is also there. So we'll say the rooted subtree rooted is subtree rooted at what? At 0. right? And it will includes, what are the it will include 0, 1 and 2. Understand? These nodes will also include. So if you take the JOR of these, what you will get? You know the JOR of this value, right? What will come? You have just seen, right? This thing, right? You have seen 1 0 0. So if you take the JOR of this, what will come? Right? The JOR in the subtree will become what? 1 0 0, right? So what is the distinct JOR, right? If we'll talk about the distinct JOR, what is the distinct JOR? What will happen? 0 and 1, right? If we'll do the sorting, what will become it, right? After the sorted, 0 1 itself, right? So the smallest one is 0, and so it is coming for the first query, it is coming what? 0, and you can see it is coming 0. The smallest distinct path JOR in the subtree of the node 0 is 0. Now similarly you have to do what for queries 1, right? Let me clear it. Okay, so now understand this query 2. What is the things we have given? Same we have given 0 2, right? So queries we have given when 0 2, it means what? We will get what? 0 and 1 if we'll do the same JOR, right? Because if we'll do this JOR, right, we have given, right, path sum is 1 0 0, and so you will get the distinct JOR is 0 1, right? So each time for the this one and this one, both we are getting what? Distinct JOR is 0 1, so we are getting 0 1. So what is the smallest one? The smallest one is 1, and so we'll get the second smallest is 1. Now it's time to understand the third query for 0 3, right? What is the thing? What will come? So only 2 distinct JOR is there, right? So it is not enough, right? 0 and 0 2, we are getting what? For the first one we have got what? First smallest is 0, second smallest is 1, right? That we have seen here, right? Now only 2 distinct JOR, that is not enough, right? So the answer will get return -1, and so it is returning -1. Since there are only 2 distinct JOR in the subtree, this and this, no other is given, and so it is giving -1, and so it is giving -1. So the total answer is giving what? 0 1 and -1. Understand? This is for the first query, second query and third query. I hope you understand till now. So let me show you something, right? Let's understand, we have given a node, these nodes, right? We have given. So if we will write like this, let's suppose we'll take node, right? Then we will take path, and there will be JOR, right? So what are the nodes we have given? We have given node 0, then 1 and then 2. You can see here, right? We have given here. So if you write node like this, let's suppose we'll write a tabular form, okay? And we'll say for node 0 what will happen, for node this what will happen, like this. If you'll write like for 0, the path is what? We are getting 1, right? Then for if you'll take the JOR, what is come? It is also coming 1. For 1, if you'll do the path, right, what is coming? This one, you see here, right? Then it will become what? 0. And for 2, similarly we are getting the path like this, right? It will become what? It's also become 0, right? And so the distinct is coming what? What is the distinct is here? Let's suppose first we'll talk about the subtree. The subtree of 0, node 0, right? Subtree at, this is u, right? So u is, we can say 0, right? Subtree of u means subtree of 0 become what? 0 nodes. What will become it? It will become what? Nodes, what? This JOR 1 2 0 0 1 and 2, right? All these 3, right? Then we can say, if we'll do the path, JOR path, what will become the JOR path? So this will become the JOR path. Understand? This will become what? JOR path for this. If we'll talk about the distinct, what will happen on the distinct? What is the distinct path? The distinct path will become what? 0 and 1. Only 2. Right? Now understand the code, what we are doing here. Okay, so first of all, we understand that what is the high level strategy, right? Or you can say what is the intuition. So intuition is to find the, you can say, path XOR from the root to the node, right, in the subtree that is given as a rooted at u, right? And then we have to find the kth smallest XOR, right, that is we have given in one base, right? And if fewer than k distinct value we have, we will return -1, right? That is the thing. So high level strategy we will use, like we will build the tree, right? We will use the DFS to compute the path XOR, and then will maintain a set of XOR in every subtree using a merge strategy, and at each node we'll check if it has a query, and then we will answer them, right? So let's continue to understand here. The very first step, what we will do, we'll take two data structure here, that is called in the first we'll take the map, another the map where we'll keep integer and list of integer, right? So this node to k list means we'll map each node to a list of k value from the queries, and this queries result map will use to store the result of each query using key format, you can say node and key, right? So we'll use node and key value pair will store in the here, right? Means first we'll take integer and list of integer, then we'll take what, string and integer, right? So node and key value will be stored here. Okay, then we'll create a custom class that is called ordered set class. It's a custom class, right? And so this class will use two data structure, that is a TreeSet, and you can say this TreeSet is XOR set, you can say, right? Why? Because we'll take this TreeSet so that we will ensure that there will be a unique values, because it is required, right? And we will use sorted XOR. We will use sorted XOR to maintain the sorted order for kth smallest lookup, that is for O of 1 times. Okay, then these are the methods that is required, right? We will use that, right? First insert method, then size method, then kth smallest method, and the merge method. So this insert method will use to add let's suppose x while keeping the sorted value, right? So we'll whenever we'll add a new XOR value, right, x XOR value we can say, then we will insert into this sorted XOR. Okay, then we'll return the size with the size method, and kth smallest we have to find using this method. And if you want to merge another order set, you can merge like this. Okay, so this method will help you to merge, right? In the next step, we will do what we know, that we have to use the DFS traversal with path XOR, right? And so that we'll use the current node, you will have parent, you have XOR, current XOR, right? And this will be your tree and the vals we have given, right? Means this DFS method will do, because the DFS is recursive method, so we'll use this to compute the path XOR for each node, and then we'll collect all the XOR in the subtree, and then we'll merge the child set into parent one, right? So these things we will do. Okay, so let's suppose we have given what we will do what first, very first step, we will do what, we'll calculate the current node XOR path, right? And then once you have the current XOR path, right, we will insert it into here into the current set, right? Then we will do, then we'll merge you can say small to large optimization. And for that, what we need to do, we'll check if the child size set is greater than the current set size, right? It means what we need to do, we'll merge the smaller set into the larger to reduce the total number of collections, right? And we'll do that. Okay, and so, and if you will not do this part, right, I have a struggle actually. If you'll not do this one, right, if you'll not merge the smaller set into the larger to reduce the total number of operation, let's suppose we can say it will come O of n log n. So
you will get that time what of n square, right? And so that you have to merge it. Okay, right, you have to merge it. Then we can say we will handle what we will handle, and we will handle the queries at the current node, right? So for each node, each current node, right, we have to handle the queries, right? And to handle the queries, right, we'll check first what we need to check, right? We will check if the current node has an associated queries, right? If it has the associated queries, right, so we'll for each k, right, for each k we will traverse, right, and then we'll return if k minus 1 largest smallest, you can say smallest XOR we have, if it is possible, you will get the result, right, you with these conditions, right? And then you will add onto the map, right? If not, will return -1, right? So you will have the current set. So this DFS will do for all the nodes. I'm talking only for the first node or even the current node, but you have to understand XOR will do recursive and it will go to all the tree nodes. Okay, you have to visualize yourself. Okay, or I can I'll clear another video where we'll do visualization. So let me know in the comment box if you want the visualization. Okay, then this is the method. It is a main method of this program, right? And so you know these things we have given, right? Means first of all we'll do clear to clear the previous data, you can say, right? And then we'll build the tree. You know how to build the tree, right? So like this we will build the tree. And so first of all to build the tree, what we need to build the adjacency list, and if the tree is ready, right, we know we have the parent also, right? So how we are going to build? So we'll build the adjacency list from the for the tree and from the parent one, right? So for each parent you will get the data, right, and you will make it ready, right? So this is your tree, right? You can say adjacency list also. So adjacency list is a tree, you can say. Then we'll group the queries for you can say by the root of the tree, right? And so for each query we can say for each query is attached to relevant node for the fast lookup during the DFS, right? And we'll start the DFS from the root node here. And then what we need to do, we'll build the result, right? To build the result, we'll start from the we'll go for the all the queries, right? And you will get the node, you can say current node, then you know the k, and you will build the result, right? So when you are building the result, right, so actually here we are doing what, we are using the current node 0 because we are starting from the root, then parent is -1, and then current is 0, right? Once this is done, right, we will prepare the result, right? To prepare the result, simply fetch the result from the map, right? You're just getting from the map and you're storing here, right? And you will return the result. I hope you understand. If you still have any doubt, right, please bring me in the comment box, right? And to do the dry run, I think we have already done, right? We have already done. Okay, thank you for watching this video. If you have any doubt in this video, please ping me in the comment box that you understand this problem statement. And if you need any help in understanding the problem, please ping me in the comment box. I'll help you there. So don't hesitate to write the question, and don't forget to subscribe and like this video. So your one like will help and grow this channel. So you will get, if you will directly or indirectly, if you support this channel, so you will get premium videos in the future, and I will get motivated to make more videos for you. Thank you guys. Thank you for watching this video, and I'll see you in the next one.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.